Okay, thank you very much. I'm utterly delighted to be here. I've been the last several days in what for somebody working on sustainable development and resilience and so on is as close as you get to nirvana on this planet, which is spending time at the Stockholm Resilience Center and the Bayer Institute, where just so much of the fundamental work years back, and I've just been blown away by the density of stuff that, even though I tried to read up on it, I didn't know was happening, that I've encountered in the last several days. So this has been a blast. I've had to alter my talk 3 times because of new path-breaking stuff I was learning about over the last 2 days. So even those of you who were exposed to part of it on Monday, I promise you it's a little different now. Why an overview of the state of sustainability science? As I'll try to argue in this case, the field, under early names of resource economics, renewable resource ecology, which is what I came up through, this has been brewing along sort of forever. But in the last really academic generation, it has taken off. I'll put some data up in a minute. But as we see at places like the Stockholm Resilience Center, at my own institute, and so on, we're really at a time when the initial founding generation are getting, frankly, old, retiring, dying off, and thus it seemed a reasonable moment that we ought to try to do from our end of the elderly and passing generation some accounting for how far the community has gotten in the big ideas we put on the table 20 or 30 years ago. But perhaps even more important, well, putting that on the table as an effort to give a broad picture accounting of where the field has come to those of you who are coming in it more recently. But much more importantly is to, in a sense, clear the intellectual decks so that the next generation of sustainability scientists, some of them actually holding PhDs in that field, are not only given license, which they didn't need, but encouragement from those of us who have been around longer to rewrite the questions, figure out what we ought to be asking today, what ought to be driving the intellectual and practical agenda, what ought we to be haranguing the universities and the funding agencies and the journals to be publishing and being interested in. So my purpose in coming on this visit, I'm on a blessed sabbatical, spending the next year trying to write a review paper on the state of sustainability science, and that is the front end of then an open-ended, open source monograph on the subject. But I'm going around trying to collect great ideas. Now, I figured for an old guy to do that, I was going to screw up so that does this thing actually work? We'll see. Okay, it doesn't need to work.
I'll put it in, and then it will work. If I can see them.
Oh, don't worry about it. I'm just afraid I will turn the machine off. Okay, you don't have to do it. I now know where the buttons are. So I teamed up with one of the new generation. This is Dr. Alicia Harley, as close to a sustainability science PhD as America offers right now. Done a lot of work on sustainability, innovation to serve very poor communities in the agricultural communities of the developing world. Has partnered with me in building coursework on this and is my alter ego in building this review, telling me, nobody talks like that anymore. That's such an old dumb question. We all know the answers to it. And why haven't you thought about power and inequity and so on? So this is a joint production, but she isn't on sabbatical, so I'm here giving the talk. Your bad luck. Okay, Science of Sustainable Development. This is a curve from a publication by Louis Bettencourt and his colleagues that simply tries to trace in some non-trivial ways the growth of the field. This is not the normal number of publications which are always going up, but actually the number of independent authors contributing to a set of journals and publications in the area. Note the vertical scale is logarithmic. So we have pretty much exponential growth, but with a couple of different coefficients. There'd always been a lot of work in conservation biology. I think for many of us of my generation, the World Conservation Strategy, the International Union for the Conservation of Nature, sort of broke the mold when back in about 1980. They moved from being a we are trying to push conservation of wildlife on the world organization to the realization that they could not do that either instrumentally or morally if that meant pushing people off the lands that they had traditionally used to produce their own well-being, clearing parks aside that now nobody could farm, which they had been doing for generations. And thus they began to push all of us in the community, but particularly those of us coming in from the ecological side, to think harder about the interactions between nature conservation and people conservation. And that movement, along with lots of other streams, is what then had led to the UN setting up, in the wake of the Palma and Brandt commissions, the first two big multilateral how ought we be doing the world differently commissions of the 1980s. They finished those two and recognized there'd been a missing part in both the notions of poverty alleviation and weapons security, which was if you didn't contend to the environment part, you were going to lose both of those arguments. Hence, the Brundtland Commission, the World Commission on Environment and Development, was born. It grew up, nurtured in Scandinavia, and interestingly had not a single scientist on the commission. That was by design of Dr. Brundtland, herself a trained medical doctor, public health official. But she said, look, I let the academics on and they will dive down into the weeds and tell you about the third significant decimal point, but we'll never get this on the high political agenda. Whereas if I get it on the high political agenda, the science will follow. Well, she was right, in the sense it got onto the agenda. You don't know any other topic that has had 3 world summits convened by the UN over the last 30 years. Literally, no other topic, not nuclear disarmament, not public health, nothing. So we got there. Science was a little slow to catch up with Dr. Brundtland's insights, but indeed by the early 1990s, Agenda 21 was sort of, every scientific agenda was poured into the bin and declared to be the science we needed to do for sustainable development. By the late 1990s, my own Academy of Science said we really need to stand back and look at some of this. We tried to, and then by some interesting statistics related to how many of the authors writing in the field knew about each other and cited each other versus how much were they just little isolated empires, the field unified in about the year 2000. And if there was an event and place that the unification happened, it was indeed here in Sweden at Friberg Manor, in large part due to the work of Uno Svedin, who I'm delighted to see is here, who was early on in one of his incarnations, saw that multiple countries and multiple disciplines around the world were nudging at this emergent field, but they were all doing it in slightly different flavors. They weren't talking to each other nearly as much as they might, and worked together with a bunch of us to actually convene a small but multinational, multidisciplinary workshop at Friberg Manor, in which we hammered out what became the first internationally articulated agenda of big questions that weren't being resolved by work in the individual contributing disciplines, but seemed to be increasingly important for this growing political agenda. And with that on, then there have been numerous journals created, institutions created, and so on. But I am here to say thanks once again to Sweden, Friberg, and Dr. Svedin for having pushed us along. Today, the field, it's a complex, multi-perspective thing, but it's an emerging field of what I would call use-inspired basic research and innovation. And in that, it's not something new under the sun. It's like agricultural science or health science was as they emerged. That is, lots of people were doing, if you go back to agriculture, we're doing agricultural economics, we're doing plant breeding and genetics, we're doing soil science, but oddly enough hadn't come together to provide science-based practical advice to farmers. Agricultural science was born in that. You have some of the leading institutions in the world here in Sweden. Interestingly, most of the work in agricultural science, and I could say the same for health science or computer science, wasn't done by people who called themselves agricultural scientists or health scientists. It was done by people who called themselves physiologists or whatever, but who came together a day a week a month, something like that, to meet not with people in their discipline, but with other people trying to address this set of practical problems. And the label, the emergence of a legitimate label, gave them cover and a convening place, almost literally a room of their own, to have discussions in which you didn't have to fight about why you were talking about something outside your discipline, but you could begin to share insights and draw on expertise from elsewhere. I think that's where we are with sustainability. If it's use-inspired, what use? Well, defined by the practical problems it addresses rather than its disciplinary foundations. And for us, by definition, that practical problem is sustainable development, on which I'll have a bit more to say. It's conducted because it is not driven by theory deepening or a particular set of methodologies. It's driven by, conducted by, drawing from whatever theoretical foundations, methodologies, data handling things, modeling approaches seem useful for the problem at hand. Again, very much like agricultural science and our predecessors. And that means that on any given moment, you will see a paper or an individual researcher in this field drawing on natural sciences, social sciences, engineering, medical sciences, the humanities, issues of ethical narrative, and so on and so on. But doing that not as a matter of necessity, but because it proves to be useful. We therefore irritate universities a great deal. The field is committed to linking knowledge with action. That's the use-inspired part, through design, implementation, adaptation of improved practices, technologies, and policies, increasingly done in a co-production mode. That is not we the experts telling you the unanointed how to do this, but working with frontline practitioners who bring their own expertise and experience into the room. We bring what we've been able to get through the luxury of some detached scholarship, and to the extent we create new knowledge in this arena, it tends to be jointly produced between the two, and therefore, on a good day, owned by both of them. Which makes peer reviewing and promotions and so on all the more problematical. That's another issue. And to the surprise of certainly all of us who assembled at Friberg back these many years ago, the field is actually building up a presence in the research literature, in degree programs, in a next generation of sustainability scientists, many of whom I've been meeting here in Stockholm, and even some career tracks to keep you from starving to death or having to revert to your origins as your careers progress. And we can go into some of those in the Q&A later if you wish. So what is this field of, what does it mean to say a field is use-inspired research? This is the so-called Pastures quadrant diagram from the work of historian Donald Stokes. And I raise it only to say that people in sustainability science are invariably pushed, pulled, stretched, beaten up on for, wait, but are you doing basic research or are you doing applied research? And those are fair questions. We need a lot of applied work in sustainability. We need a lot of fundamental research on human environment system interactions, on ethics on a crowded planet, and so on. Sustainability science, though, sits in what Stokes identified as a more realistic quadrant, not a single dimension, of basic versus applied. That is, in a quadrant that was, yes, driven by considerations of use, like engineering, but also driven by a quest for fundamental understanding. That is, understanding that would move beyond a given project in a given place and be, at least in part, transferable with due attention to local context to somewhere else. So in a sense, it's like building the textbook you would read as a civil engineer, okay? That is drawing from physics and material science, is talking to you about the general problem of building roads or bridges, setting you up to do that, but is no conceivable substitute for then doing the on-site field analysis you would need to build a particular bridge or a particular road in a particular political, geophysical environment. So we're trying to sit in that middle ground, and many of us then go spend, as Pastures did, some of our time doing pure applications up in Edison's quadrant, using what we've learned to do a project in a community. Sometimes back doing some of the most fundamental, exciting research going on the complexities of human-environment interactions. But the key is there is this quadrant where we come home. That's our umbrella, where we're allowed to talk to each other as problem solvers rather than as particular consultants or advisors in a given field situation or as basic researchers. And it's worth thinking about good people and famous scientists, some of the ones around the walls here, particularly Mr. Pastures, lived in that quadrant and said in his own biography, "I got where I am today by spending my mornings in the laboratory, inventing the germ theory of disease, my afternoons in the field talking with veterinarians and herders and dairy maids to try to figure out what was causing differential patterns of mortality and disease." And it was his ability to move back and forth between those that let him make many of the advances he has. So I know it's an uncomfortable position to be in, but it has good precedent. And just tell people you're being like Louis Pasteur and to get off your back. Practical problems it addresses. So which practical problem? The dilemma we face is, captured in 2 slides, this is what I do. The fact is that since the middle of the 19th century, virtually everywhere on the planet, there has been what Angus Deaton calls the great escape. Improvements in lifetime duration, that is life expectancy, the quality of life, the rarity of hunger. There are surely pockets of poverty left. There are surely regions left behind, but this is phenomenal. You can go back 4,000 years of human history and that curve never budges. The average life expectancy sat around 30, 35 years, and then mid-1800s, it rockets up. And within a period of 50 years, it rockets up everywhere. You feel, wow, we must be doing, development, whatever it is, must be doing something right. The problem is that at the same time, I could have done the carbon dioxide in the atmosphere figure, I could do the mercury in Arctic wildlife figure. They all look the same way as this, which is the extinctions figure. We are almost on identical time scales. We are utterly transforming the planet on which we grew up. And the dilemma in front of us, the central challenge for sustainability science, is how on earth can we maintain the improvements in human lives and livelihoods reflected on one side of this diagram in the face of the devastation to the biosphere and nature going on the right side of the diagram, without eventually, in English at least, the chickens coming home to roost and these life expectancy curves turning over. But it makes a very hard argument for us because the people say, like, you've seen a better era in human history for improving livelihoods? All of these thinking back to the sustainable civilization of X, Y, and Z, that sustainable civilization almost always had 5 or 6 kids born of each family dying before they were 5 years of age. People were dead at just about the stage you're starting to start your careers. Life was nasty, brutish, and short. And for a lot of people today, it isn't nearly as much so. And so the question is how we set conditions that the rest of the world that isn't at the top of that human well-being curve can bring themselves up to what they view as a good life for them. At the same time, we contend with these monumental transformations of the biosphere. So the Brundtland Commission, 1985-87, said our goal ought to be, it's interesting to think of what they said, it ought to be finding pathways of development, of doing stuff to serve ourselves on the planet that serve the needs of today while not damaging or undermining the ability of future generations to meet their own needs. And that's gone through several iterations. Most recently, It's turned from that nice, simple, memorable statement into the Sustainable Development Goals articulated very recently by the United Nations. And all these things in the boxes, which you can pursue on the web anywhere you wish, are neat things to do, but they've become somewhat problematical in that it says if sustainable development, what Brundtland was aiming for with her needs now and in the future, is doing all these things, building partnerships, saving the oceans, this, that, and the other thing, we really risk encouraging everyone to keep doing what they were doing anyway. And we lose what in my own second career, which is policy analysis, we understand to be the difference between the goals each of us can have as an individual. You can be in favor of whales, and you can be in favor of good government, and so on and so on. And that's fine, but if we now have to cooperate together to solve some of the problems facing us, we also need, besides your individual passions, we need shared passions. We need things we can look on as a common goal that attracts all of us. And the SDGs in that sense were a step backwards. Again, not that any one of these goals is a bad thing to pursue, but that we lost the bubble that Brundtland had given us in a somewhat crude, non-quantified way. Fortunately, in a parallel set of developments, the concept of human well-being as the ultimate goal of all this stuff has emerged as the successor of Brundtland's meeting human needs now and in the future, and that has been viewed as a little bit too constructive. I mean, human needs sounded like you get just enough food to eat and not be hungry, just enough energy to read books at night, and so on. Clearly people long for more than that. And so the notion of well-being has been emerging in everything from philosophy through the practices of the World Bank as the successor of the Brundtland vision, but with the notion that it's multidimensional. Your definition of what makes a good life for you is almost certainly different than your definition of what makes a good life for you, and is virtually certainly different from what people on the other side of the world, facing different realities and different histories, say makes a good life for them. Equally, it's become increasingly clear that what your grandparents would have said is a good life, and what your grandchildren or their equivalent will say will be radically different. So we have to be thinking of this idea of well-being as, yeah, it's a concept we can all come together among, but it is one on which differences and pluralism will be the order of the day. So what do we do with that? I raise this simply as you want to explore a bit of that. You can do it on all sorts of websites and so on. The OECD has run a lovely Better Life project, mostly grounded in the industrialized countries. Lots of focus groups. What are the important things that make life good for you? And they did that all around the country. They came out with this list of 11 things that appeared really frequently, though there are another 55 of them that appear sometimes. And they set them up in a website in a way that you can run those sliders and say which of them are most important for you and which are least important. And they will generate then your characteristic notion of well-being. And they will then take that and compare it to the average or modal vision of well-being in each of the OECD countries. And you can identify which country you would be happiest in. It's somewhat surprising, but you're going to have a lot more immigrants into Scandinavia. Sorry. The point is there's variation, but the point is equally lots of groups are coming around to this notion. Now, equally important, though, is that from Brundtland on, it is not just equity as an average, it's not just well-being as an average quantity for everybody. It is well-being with explicit attention to its equity dimensions. That is, that this be a broadly shared equity, that it bring up the people who have, or allow the people who have the lowest well-being today to come up. And if that requires some damping down of excessive overconsumption by others, that will be part of the deal too. That is, the normative push for sustainability today turns out to be about development being thought to be sustainable when its success in enhancing our well-being in the here and now does not come at the expense of decreasing other people's ability to shape their own well-being, either on the other side of the world because that's where we dump our garbage, or in future generations because that's whose climate we mess up, or that's who we dump mercury on, and so on. So it is this shared well-being around the planet. Now, that said, it will not escape your attention that that's not how it is today. We are not in a situation where well-being or the opportunities for pursuing it is remotely evenly shared around the world. Rather, it is sequestered by a few who reap many benefits of well-being for themselves and at the exclusion of the many. And so you can argue how you want to measure that. The important message is sustainable development well before it's a technical issue that people like us in our offices deal with. It is an inherently and centrally political issue. It is a redistributive issue bigger than the argument between the social democracies and the market democracies and so on. It is hugely redistributional, present to future, present rich places to present poor places. And as such, it means if you go into sustainability science as an expert, you are going to be beaten up by interests who don't want the kind of insights we produce to be out there, because almost certainly the rich and powerful today are going to have to give stuff up. And that means that radically differently than pursuing most basic sciences, you've got to be prepared to go to war. And your bosses have to be prepared to give you cover. And you've got to teach yourself to be pretty politically savvy. And it's hard work, and it's not altogether enjoyable. So, in all this, what's the role of sustainability science? I borrowed the phrase from the philosopher Amartya Sen. If political agitation is the heart and soul of sustainable development, the redistribution of opportunity, then our role as academics is to inform the agitators, to make sure that they do not, as much as possible, waste their time and precious effort on things that don't make any difference. That they don't push forward, as sadly many of us did, unsophisticated views of, say, requirements for percentage use of biofuels in feedstocks, because that's all they knew about, when any one of us should have been able to do a study in 3 afternoons that would have predicted some of the downsides, whether it was deforestation or food price spikes that resulted from those mandates, both in Europe and in North America. We need to inform agitators on the front line about how transforming business as usual, which is not equitable in producing well-being, into the kinds of trajectories of human activity on the planet that would be more consistent with this idea of inclusive well-being as the goal of sustainable development. It requires raising our ambitions from the treatment. If I use the health analogy again, medical science spent a long time focused on treating individual acute diseases. And that was really good for many of us, because we would be dead if they didn't do that. That said, they came very slowly to the understanding that ultimately that's a losing battle. What you need to be doing is radically investing in improving life quality, wellness, for people throughout their lifetimes, so that you have many years of a good and active, healthy life before you. And that doesn't say you can ignore the acute diseases any more than we can ignore a given new proposal to do mining in a protected area. But it does say it means we have to rise above those individual concerns with the acute damages being done to the world, and think about what would it mean to transform the trajectories of development in a direction of planetary and people wellness, whatever that might mean, and that's our problem to define. But it means mostly getting out of our comfort zones of addressing particular pollution episodes or conservation issues to also, not instead, but also address these broad patterns. It pushes me to think tentatively that means the unit of analysis, if I can come to the science part of this, that ought to be central to sustainability science, the thing we study and try to explain, is not the individual acute episode of pollution or extermination of a species, but rather long-term, large-scale trajectories of development. Okay? So why and how was it that Europe got itself onto a trajectory of acute fossil fuel dependence rather than one of renewables dependence? Okay? Over large areas and long periods of time. What might we do in what is, I gather, the Energiewende to move us back in another direction on that? Think of agricultural trajectories from small, relatively localized food production and consumption to massive globalized assumptions. How do we come back and think about steering not just individual crops or zoning laws, but transforming how we do agricultural services, energy services, housing services over the long and large scale? Work of sustainability science then should be to help society assess the sustainability of current development trajectories, just like your medical doctor assesses how are you doing given your lifestyle, your age, and so on. Are you healthy or not? Or do you have to change something? So assess the current state of well-being, diagnose the causes of departure from well-being. Many of you will have had the sad experience of your doctor saying, you're doing pretty well, but you know, I don't like your cholesterol levels or your blood pressure. I mean, that's mostly for us old guys. But there's this one thing, or these two things, if you're lucky, that really aren't quite what they should be. But I've figured out what they are, and therefore we can now start talking about things you might do differently to get this trajectory in a fully sustainable direction rather than one that has certain potentially lethal flaws in it. And coming out of that, to prescribe, in consultation with our patient, the planet, society, things you might do to remedy those shortfalls. Okay? So I realize there are dangers in the analogy of this is like medicine, but I think it helps to say we need to be able to say how healthy is this trajectory of society, what's wrong with it, and for those things wrong with it, what would you do to fix your blood pressure or your cholesterol levels or your obesity and so on and so on. Okay, so we've been working in this field for 30 plus years. And all manner of frameworks, mostly with acronyms associated with them, have been invented to say if you just look at planets and the people this way, things will be fine. Or you'll at least get some leverage as a scientist. And they've all done good stuff. I don't think almost any of them, except maybe donuts, have been demonstrably harmful. But looking at the real complexity of Earth, we've had a bunch of human environment, social, ecological perspectives that try to couple the natural and social side. We've then had rather later in the game, coming out of work in the Netherlands and Britain particularly, what goes by the name of social technical transition stuff, very little early attention to environment, but really concerned about how the evolution of technologies and institutional structures transformed everything about society, including how humans made use of or abused natural resources. And they pulled us back to these long-term transitions, to the necessity to look at history. And you could put 6 other frameworks in this. Where it leads me and my colleagues, at least, is to think that, though I don't have a good acronym for it yet, we are now looking at the interactions of environment and development in the Anthropocene as a complex adaptive system in which the ultimate driving factor is not population or world trade or whatever, it's innovation. That is, it is that new ways of doing things. Technologies, rules and institutions, norms of what is good behavior and bad behavior, acceptable behavior or not for states, come along and transform us from being a bio-powered society to a fossil fuel society, or a society that recognizes universal human rights when one previously didn't. It is these transformations, these generations of novelty, that if you look at histories of 100 years, 200 years, are the things over and above all that are determinative of the big transformations that we see, and thus we ought to expect to be central to the future trajectories. And the question is how we grapple with these, knowing that we can't predict in advance what those innovations, again, in technologies, in institutions, in norms, might be. So, whatever framework you adapt, the central, in a sense, the central question for sustainability science, certainly the one that the activists were putting to us from day one, was, so, okay, I get it, you're trying to sustain well-being intergenerationally, equitably, what do I need to sustain? What actual thing do I not want to deplete too much of? And I will say that in the mid-1990s, early 2000s, we had nothing to give them. We tried to edit that chapter of our National Academies report, and we ended up with just garbage. We had 57 different indicator systems that people were pushing. None had better scientific foundations than the last. It was embarrassingly bad. And the situation here in Europe wasn't much better, except that you had the Bayer Institute. And there, with some of its own resource economists, and people it managed to provide the focal point for bringing together from around the world, not all of them economists. They began to extend old development thinking that thought about land, labor, and capital being the determinants of countries' strength into a much deeper view of whatever it was you needed to sustain. First, it had to be a capital stock. It had to be an asset, not a flow. It makes no sense to say, I want to maintain the flow of money I'm taking from the system, because it doesn't tell you whether you've just taken it all, or the flow of water I'm extracting from an aquifer. What matters is how much is in the aquifer, right? So the big push was to say, you've got to think in terms of asset stocks. Now, we can argue forever, and we are arguing forever, for what those asset stocks are. But they said, if you're going to sustain something and say, that's what I will measure to tell me whether I'm on a sustainable trajectory or not, you've got to come back to some notion of fundamental assets that people then draw on in order to produce the flow of goods and services that create their well-being. So we have the goals of inclusive human well-being. We have this complex adaptive system. And the question then is how we think about these underlying asset stocks that this complex system draws on to generate well-being. As I've struggled with this myself, what I have found most useful is an image. This is Solar Impulse 2, the plane that flew around the world on totally solar power. And what I want to do to get you to think about what it really means to say it's asset stocks we're concerned about is, to a first approximation, the pilot of that plane watched 3 dials. One dial was the compass heading. Am I heading towards the right goal? Second one was the velocity, airspeed. Am I getting there at a reasonable pace so I don't run out of food or whatever? But the third was the battery. Was the amp hours still in the battery, which charged up during sunlight hours and went down over dark or cloudy time? That stock of amp hours in the battery was the asset base that would determine whether this flight plan of going around the world was sustainable or not. Or you were going to, in the middle of the night, one day, in the middle of the Pacific Ocean, run out of it and come crashing down. The question for us becomes, what is our equivalent for the planet of the amp hours in Solar Impulse 2's battery? And recognize that as important as the compass bearing and the airspeed were, those just tell you, how are you doing right now? Still headed towards your goal, you're doing progress. It tells you nothing at all about whether your battery is retaining enough charge, and maybe you have to change your goal a bit. Don't fly into the headwind. Maybe you have to change your speed a little bit. You're not going to get there as fast, but you won't burn down the battery. It's the battery that tells you whether it's sustainable. So what's our battery? The concept of inclusive wealth is what bubbled up from the resource economists and their colleagues. Wealth being the amp hours in the tank, inclusive being that we don't just care, just like with well-being, about the average amount. We care about how equitable access to the use of that battery is to people across the planet. So inclusive is the equity dimension here, just as it was with well-being. So fine, what real stuff in our world are those stocks of capital assets? I use this image, which is my simple version. All the assets that matter to us at the moment, you can see in this figure of a fisherman, could be off your coast, this one happens to be off our coast. And half the assets are due to nature, half are due to A for anthro, us. So the biota, if the fish weren't there in the ocean, the fishermen would not have a viable lifestyle. So biota, check. We need that as one of the assets, and if they're all depleted, we're screwed. Second, physical chemical environment. If the ocean is so polluted that sooner or later the stocks of fish are going to die out, or the weather is so contaminated with carbon dioxide that the storms are coming more intensely, are unpredictable, and so on, the fisherman's going to die. Minerals was harder, but in fact, if you look closely, he has orlocks that are metal rather than wood. And without those, it would at least be harder to do this, and you would be more likely to break your ore grounding. And finally, geography. Yeah, I know. Geography saying that imagine this were a fisher and we're trying to do this from the middle of land in northern Sweden. That is, if you were trying to pursue that lifestyle and you didn't have an ocean nearby, you would be in toast. And it's so obvious that we often forget that as you begin to do comparative work on sustainability and say, well, why are these people doing well? And it matters a huge amount where you are. Are you on steep mountain slopes? Are you on coastlines? Are you on rivers? Are you on low elevations that are charged with lots of diseases, or at a nice optimal elevation? So geography matters too, and there's a lot of room for physical and human geographers in this stuff. Okay, then you go down to the anthropocentric, the derived from society assets. What do you have? You have first human capital, which is the fisher himself. I think it is a him in this case. If the fisher were weak with disease, he would be in very big trouble out here because it takes a certain degree of strength to do this. So human capital, health. Human capital, education. He may not have had a university degree, but clearly if he's doing this a lot, he knows a lot about fish and weather and so on and so on. So the two big elements of human capital that you see now reported in the World Bank and so on, those become essential assets to sustain. And if fishers stop telling their kids about how to fish, you're in trouble. If fishers are being poisoned by mercury in their water supply, you're in trouble. Manufactured capital is, of course, the boat. If we have no boats, we have fishers standing on the shore with spears. Social capital, that's the rules by which we regulate interactions with one another. You don't see a lot here. You see one boat up on the horizon. But we all know from work on fisheries that a whole bunch of the story is whether we manage to somehow regulate the number of fishers that will be pushing on a particular fish population and have rules for limiting catch to sustainable levels. So without that, this very quickly devolves, if the technology permits, into overexploitation. And finally, there's knowledge capital. Imagine this fisher drowns. All of his knowledge about weather, fish stock population dynamics, and boats disappears, but with luck, that knowledge was also embodied in publicly accessible forms. Shift to modern times, in libraries, in patent offices, in cultural knowledge and stuff handed down across generations. So it's the body of public knowledge that is not simply located in one person's personal learning and experience. So that's the bundle of assets. Now, even 10 years ago, we started flogging this and we started doing lots of measurements on individual ones. The ones many in this room are familiar with are the notion of nature's capital, by which mostly we've meant the biota, or the biota and their ecosystems, and the ecosystem services flowing from them. But there's been almost comparable amounts of work in the stocks and flows of benefits from each of those 8 capital assets. But we sort of said that, and people would still look and say, but what are you going to do with this stuff? Well, the answer is people are doing stuff with it. This very recently published study from the Netherlands, Harry Linssen and others, has taken the Netherlands, gone back to 1850 and looking ahead to 2050, and they've actually accounted for its development in terms of a limited but broad subset of those capital assets, and how well or badly they have in fact translated into well-being as defined both from today's perspective but also the contemporary perspective. That's not just done for individual cases, though I would commend this book to you, which I should say is open access and freely available. The World Bank is now regularly publishing data for 100 and something countries of the world, in which they do a first approximation of how these asset classes are moving. The color codes here are if you're to the orange and red side of things, the total amp hours in your battery, the total value of your stocks is declining. If you're in the green and yellow side, they're increasing over the period 1990 or 95 to 2014. These are very approximate. They don't include everything. It may shock you to see that China and India are on sustainable courses. And mostly that's because of the huge investments they've made in human capital and a little bit more of that in manufactured capital that doesn't negate but outweighs the damages they've done to their environment along the way. The point isn't these numbers are right, but that they are now operationalized, internally coherent theory that begin now to drive better data collection efforts, improvements in the details of the theory, and finally, 30 years in, an ability actually to come back to people on the front lines and say, okay, to a first line, we can actually tell you based on science, theory, and data, which places in the world, or which sectors in the world are on sustainable development paths and which are not. Then we can go into the diagnostics of why we have bad news some places and better news others, what we might do about them. That's a lecture for another day. You've in fact had many people in the Stockholm series that are picking up from that diagnostic and prescription viewpoint. What I've wanted to do with this presentation is stress the notion that that's great stuff, really important, but if you want, the big contribution of work in sustainability science, I think, over the last 30 years, has been to build this underpinning of being able to say, what are we trying to sustain? How would we measure it? How do we aggregate that together to give us a picture of the wellness of, or bad health, of our interactions with the planet, rather than merely be down in the important work of treating individual diseases of pollution and resource depletion and so on. So let me leave it at that. Invite questions, commentary. This slide deck will be available however you make such things available. It's got contact information for Dr. Harley and myself at the tail end of it, along with a bunch of embedded citations for most of the science studies behind what I showed. But thank you so much for having me, and I will welcome comments now or in the indefinite future. I have a review to write, and I don't know what to put in it. So tell me about your really most exciting work and the questions you most wish people were funding because you would do the coolest sustainability science on it. Thank you very much.